This conference will now be recorded.
Hey everyone. So 3 agenda items today, assuming Nick joins. One is Cliff doing a update of the wrap up of the Chiplet Summit. So Ravi, if you want to add your thoughts. Okay. After Cliff, with Cliff, anybody else who attended, please feel free to do so. And after Cliff, it's going to be Travis and Nick for 15 minutes each on business challenges with chiplets. So we're spending all of February on business challenges. If your company we've got about 9 companies lined up. We've got about 3 more slots. So if your company is, and Travis is nice enough to be the first guy to volunteer, so thank you. And so if your company would like to present, please ping me. All right, Cliff, it's all yours.
Thank you, Bobby, and thanks everyone for giving me a few minutes. I wanted to give everyone an update on what I thought was, and the foundation thinks was a very successful showing at the initial Chiplet Summit. First of all, the Chiplet Summit itself was very well attended. From what I understood from the organizers, there were about 500 people in attendance, and they credited OCP with driving a couple hundred of those attendees based upon our outreach and having a tutorial there and having our keynote. Also from objectives that we had for attending the Chiplet Summit, I think we very much accomplished our mission. One that was to showcase the new announcement and the work going on between JEDEC and the OCP, and specifically CDXML, to make that a global worldwide standard, which we had a lot of extremely good press in the marketplace and gained a lot of recognition and stature for the ODSA project. The other very important intention of attending the Chiplet Summit was to focus the perception of ODSA out in the marketplace to being an entity that is now focused on an open chiplet economy and enabling and everything required for enabling that, from business workflows, technical workflows, test environments, standardizations around comparing chiplet interconnects, standardizations around chiplet interconnects, and really being a group that's focused on all of the enabling requirements to have a true open chiplet economy. We also were lucky to gain support at the Chiplet Summit for some of the work going on at the Department of Energy, looking at high performance compute. And without making any promises, we now look forward to a potential workshop for an exchange of ideas with the DOE at the Lawrence Livermore Lab sometime in June. And there's also potential that the Lawrence Livermore Lab would sponsor a space where we might be able to set up a chiplet lab that's focused on high performance compute and energy efficiency. And that, if everything goes well, that might open in advance of Global Summit. So again, those are things that have been kicked off because of our presence at the Chiplet Summit. The other thing that I think was very important is I had a number of companies come up to me that were not engaged with ODSA and now planning to become OCP members and join ODSA and begin working with us in a broader context. And so I think, those were some of the most important comments that are really important. It's one more thing that I think the feedback we got during the analyst briefings, pre-brief for the summit, and during the summit, was that the next really important hurdle in terms of creating an open chiplet economy is really around solving the business workflows. As much as chiplet interconnect remains important, and the community I know is hard at work at advancing that, and we're looking towards BOW 2.0 later this year. In fact, in April timeframe, the business workflows is the next big challenge. And luckily this month, we've had, I think Bobby was saying, 11 companies step up to share with us what are some of the business challenges and it behooves us to set up a program where we can work on some of those as a community and publish some results later this year. So very important understanding of where we want to go and put a focus for ODSA on the business work stream for this year. Bobby, that's really what I wanted to share with everyone. I'm not sure if anyone has anything else to add who was there. I know some of the people that I see on the call here were attending at the summit and might have some other thoughts they want to share.
Uh, Actually, Cliff, the only thing I want to echo is, yes, it was very well attended to my surprise, because this was the first time this chiplet summit was done, but very well attended. And the panel which Bapi was talking about, there was a chiplet panel on business model, and thanks to Travis and other panelists who shared their perspective, and that panel was actually very well received. I think room was packed with 70 or 80 people in the room, and I don't think there was any other room left in for that to accommodate more people. So I think looking forward to see what chiplet business work group as part of ODSA can drive, and some of those workflow you're talking about. And as Bapi said, we'll be spending quite a bit time in as a speaker lined up. Well, that's all I want to add.
So I do want to say one thing. I think Cliff spent a lot of time. We spent decent cycles on promoting the concept of a chiplet economy in terms of the way to describe ODSA. To that, it's about not just about the interfaces, but the actions and actions needed to establish a viable chiplet economy, which is what our sort of business February is about. But I've shared the deck we created with everyone on the ODSA mailing list. That's number one. Number two is, I think it's incredibly exciting. We have first silicon for Bo. It's unbelievable that we've got D-Matrix demonstrating first silicon, and as long as Elad's not on the call, because he'll kill me for mischaracterizing. But I think there are some cases where the power per bit was lower than what the spec calls for. So that's really exciting. And Cliff, last thing, this is a hot issue. It's Lawrence Berkeley Lab, not Lawrence Livermore, because and that's it. But jokes aside, there's a reasonable chance we're looking at a June workshop at Berkeley Lab. So I'll send out more information about it as we figure it out. But it'll be and it'll be chiplet focused, and I'll send you some thoughts on what the focus areas are as we go forward.
Yeah, thank you, Bobby. And I just wanted to add one thing on the Lawrence Berkeley Labs. Thank you for the correction. Is that the expected outcome is that after sharing of chiplet technology and the problems faced by the HPC community at LBL, we would put together a report including recommendations to, I guess, the lab and government or DOE as to how they might help move the whole open chiplet economy forward, and that might lead to some funding available for certain projects.
Let me know, guys, if you need any help. I'm actually quite tied to the DOE, actually. I know that, and I got some speaker for DJ also from that side of the world. But let me know if you need any help.
Nice.
With that. Sure.
Thanks, Tawfiq. That'd be really good.
Just to add as well, I was there. It was, to echo Ravi, it was a well-attended summit and a tremendous amount of excitement about for us in our industry. So, and congratulations to OCP, the ODSA team. You did a cracking job of giving Bunch of Wires a good stage, and Elad did a fantastic job on a bunch of the panels. Certainly said, we're here to stay. UCIE is going to put us in the corner. So, well done, guys.
Oh, nice. Thank you.
Guys, can anybody, like, maybe in 5 minutes, summarize?
Yeah, this is Nick.
Takeaways from that conference. Like, what's most impressive papers or talks or that you attended?
For me, the panel sessions where they got deep into the discussions, what I felt really came across clear is, when you're chopping a monolithic die in half, in making it into two separate pieces, you want it to be super, you don't want to add any overhead or any power. Ideally you want everything to stay the same as a monolithic. And what Bunch of Wires does is it really gives you the lowest power, the most efficient, the least overhead in your die area to do that job. And there was some heated debates with UCIe, whereas UCIe is it throws in the kitchen sink of doing everything. They both have their place. I got a feeling that there was a desire that if the two could merge. When I spoke to different people, there were several camps. There were 3 basic camps of, maybe on the organic level, Bunch of Wires is better than, and far more advanced than UCIe, and UCIe is more silicon substrate level. The other thing was people were saying, well, Bunch of Wires is probably going to be legacy, and UCIe will take over. And the others were, no, they'll coexist as 2 completely separate standards. They'll both have their place. And that's the shortest summary I can give, Tawfik. But there was a lot of topics covered, and I mean, from my perspective, I think it's a great democratization for our industry that the smaller companies can actually play in the chiplet space, can actually contribute to our industry again, whereas at the moment it's consolidating to just the big guys, obviously. So there was a lot of excitement. That was from the discussions I had.
I just have a comment here. I think what was really interesting is that there is indeed a chiplet ecosystem that's starting to develop. When I looked at some of the demos and some of the prototypes that were out there, it was really interesting to see the work that Apex has done, taking Ventana's RISC-V and DreamBig's IO Hub, putting together interop systems, which everyone's very excited to look at. And so I think the evolution to get to this ecosystem is important, because that's what's going to either make it or break it, right? I mean, BO, UCIe, those are important pieces, but ultimately, is this really a good business for a whole bunch of semis to put all their eggs into that basket? Some of the questions that possibly need a lot more debate is, I saw this one slide, which I didn't attend this panel, but my colleague did, and about revealing wafer yield to customers, right? If you're selling a chiplet, those are things we typically don't want to do. So those are still questions that need to be answered as part of an ecosystem. If you're going to buy chiplets from other people, how do you go about revealing certain things and not revealing certain things, but still making it a viable business? Certain companies won't want to sell chiplets to other companies. So there's a lot of ups and downs in this. But I think really the point was there is an open discussion, and everybody's trying to think through how to work through this to make this ecosystem a reality. That's my 2 cents.
Thank you.
Did you want to add anything?
Oh, Bapi, Nick here.
Yep, you were about to speak about 3 minutes ago.
You're talking to me yeah. So it was a good conference for us. We were obviously one of the exhibitors, and I gave a session. I presented at the session and also moderated a session. A lot of excitement. I think this is an area that's breathed new life into the semiconductor industry, because it is given new options for us to build systems and solutions. So I think it's added a new dimension to our ways we can get things done. But I think there are still a lot of challenges ahead for the open chiplet economy, as we call it. And for everybody on the call here today, Bapi and I are going to be on a webcast next week, so on LinkedIn. So I invite you all to either listen to it live or watch the
replay of it later. And where we are going to talk about some of these issues about how we get from where we are today to something that you can actually order the chiplet off the shelf. And I'll talk about some of those challenges later during my 15 minutes of fame. But, again, congratulations to all of you that were there and participated, and we're showing your capabilities, and congratulations to D-Matrix for getting the PHYs out. It's a great first step. Thank you.
All right. I do want to say the one slide that stuck to my surprise, with at least in our talk, was the belief that chiplets are eventually going to be everywhere chips are, and the ramifications of that thought. That slide was actually much stickier than I'd anticipated. It was a claim I made from a cut and paste of a report by Accenture, and the claim we made was chiplets will eventually be everywhere chips are. And that sort of led to a natural conclusion that it's hard to see one magic interface being able to meet all the universal requirements across all these domains. Travis, it's all yours. And Ravi, I'm going to hand it over to you in terms of running this. I'm going to take notes.
Okay. All right. First, I want to apologize to Boppy and Ravi for getting my wires crossed on which panel I was on last week. So thank you for working out and accommodating.
That was hilarious. Like,
yeah. Anyway, let me see if I can share. Okay, this shouldn't be too much surprise to everyone, especially if you're at or on the panel last week. Most of these were talking points that came out of it. The first one should be absolutely no surprise to everyone. The first thing that comes up with any kind of customer discussion that I have is, BOE or UCIe. They want to get to the bottom of it. Our engineers are like, hey, BOE's here, it works, we have it going. Customers are often hearing a lot about UCIe. I think that's the way it's going. I won't say too much more about that. I think we're all very familiar with it. But again, no conversation starts without like an extensive conversation about that. And kind of, I don't have it on here, but similar to that is a discussion about like, well, can you use chiplets from different companies together? And some people out there are messaging differently, like, oh, sure, there's a standard now, but it's going to be one company integrating it together and doing all the chiplets. Obviously, I'm from Ventana, we have a very different opinion about that. We're working with Dream Big, whereas another company called Leapfrog, who has another product which will hook into the Dream Big hub, and there's others that we're working with. So I feel that question's answered. It's like, with standards such as BOE, that's certainly achievable now. The other thing that comes up, again, if you're on this panel yesterday, again, over and over again with customers, hey, who's going to be responsible for the final product? I personally don't think that this is that difficult of a question, but it's obviously hanging out on people's mind. I think we had a good discussion on this last week. It is ultimately a business discussion, and B, things like this have been solved before, just like the IP model. Okay, when you do an SoC, you have IP from different vendors. How do you work it out? And so there's a model in place for that. Again, silicon's a little bit different, so there'll be different things to be considered, but it can be worked out through business discussions. Another thing that people want to know is how low can you go with chiplets? Everyone knows that you can do it for large data center class chips, but with some of these things that have been worked out, BOE should be a little bit more cost efficient. There's new packaging technologies that's coming out, so everyone wants to know, like, well, how low can you go? I don't have off the top of my head. I think Ravi gave a good answer yesterday. There's some tables out there. I don't know how up to date they are, but it's almost like you could set up a website and put a cost model in there with all these different things that you probably get like a million hits. It seems like that's like a question that comes up over and over again. They want to know, is it changing over time? How quickly is it changing, and can you apply to things besides data center chips? Another one that comes up over and over again, and again, people have passionately different opinions on that, is security. Again, this came up, of course, in the panel. And my stance on that is like, hey, yes, it's very real, but as with many of these security issues, it can be maybe a little sensationalized. There's various security companies that want to, solve their security solution for it. There are some new concerns with chiplets. Hey, if you're going to have like these high degrees of coherency, different masters on the system, how do you make sure that they're not snooping into where you want to go? But again, we've worked this out within the IP area. You have trusted companies. I don't think you can just go take a random, black box chiplet. I mean, there's enough money at stake that you're not buying stuff off the bargain bin. Yeah, maybe one day we'll get to that chiplets, but at least today, there's probably going to be a finite set of companies providing these chiplets, and you're going to know who they are. So just like with IP suppliers today, yeah, you'll probably figure it out. And again, sure, we're dividing stuff up and there's some visibility, but before you had SOCs, things were, separate components on the board.
Hey,
Yeah.
so this whole idea of, in the previous slide, how low can you go? Why does that happen to chiplets and not with IP? Let's say, is it just because the IP model is well understood?
Well, there's overhead when you do chiplets, right? Like how low, there certainly when you get into advanced packaging, like when I was at Qualcomm, for example, we did a breakout of it and like, oh wow, we sell chips and like you have to be in the multiple hundreds of dollars to go and do this before it gets interesting. It adds too much cost. So, and so certainly when you say look at some of the substrates that you use, if you're doing a large one, these substrates itself can be like, I don't know, $50 to $100 to adding onto it if you can get a hold of one right now. And so like intuitively, most people are like, okay, if it's like a $400 to $500 chip, no problem. But the question is like, okay, well, can I use this for like a $100 chip? And that's what people want to know. And in my mind, it's pretty obvious you can't use it for like a $10 or less chip. So the question is, can you use it for a $100 chip? No, I don't know. I have to go run the math. I don't. Somebody in this group may know off the top of their head where the threshold is right now. But I think people want to know, okay, like offhand, is there a number we can throw out there to tell people when they can start thinking about chiplets?
So Travis, the problem I see with that is, let's say there may be a floor, I don't know. But how do you filter in IP reuse costs, the advantage of doing things in different process nodes? Like, how do you filter those into the cost model, right? And even stuff like maybe opportunity cost.
Yeah, those are good questions, and that's actually part of our pitch. Is like, hey, you're not having to license IP, but I think at a first order, even if you just put aside the IP licensing cost, like there's just a straight up question of if I break my chip into different chiplets, like where does what is the cost of doing that? That's just the first order question, and then to your point, yeah, it does get multidimensional very fast after that.
Yeah, so like the cost model that we worked on through Ravi's business group, I think, I don't know, a year or two ago, that one sort of gives you a pretty good idea of, hey, I got this giant 3 nanometer SoC and I'm going to break it up into 4 pieces, each in a different process technology. And here are the yields based on defect density, blah, blah, blah. And I can calculate the silicon cost. I can calculate the cost of additional IP I have to purchase for interfaces, and all of that. So I think that is not as difficult as some of the less, some of the things that I find it very hard to put a number on, which is kind of IP reuse cost, which is really like from your point of view, your product roadmap, where do you see you could use this piece of IP 6 times? And so now your development teams can actually do something else as opposed to integrating this IP into another SoC. Just, those are the places I feel a bit of a vacuum, and my inability to define that clearly.
I would agree with you. It's a very difficult question, but I think like the content you've already created, maybe I just haven't searched for it. I'm new, so maybe I naively don't know where it is, or maybe it's more publicized and I just haven't run across it. But that content that's already been created, maybe we just put that a little bit more prominently. It pointed that to the first order question, but then maybe we can take a crack at the second order one too.
Is there any merit? I mean, part of the reason we're doing all this is to sort of identify a set of things that the business work group can do. And is there any merit to taking the spreadsheet that Anu and Anu Mudassir and Javi developed and customizing it to sort of say a Ventana-centric system architecture? To sort of say, okay, here, if you take a specific, and then any other company who wants to do it can do it, but to sort of say, look, we've adjusted the numbers, and to whatever degree numbers can be disclosed, and saying this is an application specific version of the cost spreadsheet. I'm asking, right? Is that an interesting thing to do?
I have to look at it. I've never seen the spreadsheet.
Okay,
So
then maybe.
Bobby, I think what you're saying is, I do that, right? I take that spreadsheet and I make it somewhat as specific to my company as I can, but I can't show you any of those numbers because I'm not going to show you what my yield is or what the cost of a wafer is, right? And Travis is not going to do that either. He's not going to share his stuff with me, which is perfectly reasonable. But what I'm saying is that is, we still don't hit the pieces that chiplets actually help, the IP reuse pieces, and maybe I'm just, maybe just I'm just swirling in this this thought that I'm stuck in this place that I'm unable to define clearly. So we can take that offline. I think I'm just rambling at this point. So.
No, but I think that's valid input. I mean, I haven't seen the spreadsheet, but maybe there's stuff that can be added to it. I mean, you can put a lot of things in a spreadsheet to create the equation. Like if you're trying to quantify some kind of number, what your IP costs and things like that. I've certainly done similar things, but again, trying to make it to a universal template would be challenging.
Right, I agree.
Yeah. Okay, I'll go ahead and close out my slide here. So the second one kind of gets into something that comes up once you start talking about it. So we have a compute chiplet, and DreamBig has an I/O hub that pairs up with it. But then we have people who say, "Hey, we want to use your compute chiplet. We kind of want to use an I/O hub." And then what becomes apparent is there's a little bit of a difference when you have a compute chiplet, which has all those different kind of system architecture components. And say if you're just using a chiplet which has like an optic or some kind of SerDes type of interface that you hook up to it, and you're just using it for transmitting, hooking up to something else. And so then you start realizing that, like, oh, you kind of have to standardize the architecture, right? So if you have like an ARM-based compute chiplet and a RISC-V based chiplet, it's going to be a little bit challenging to hook them together, even say if you're using the same bus. If you're using an AXI or CHI, that's one thing, but there's certain boot flows and initializations and things like that that come up. And typically you don't think about it as much. When you have your own SoC, you have your own SoC kind of system architecture stuff, all these little things that you think about in your flow. And when you start putting together all these different compute things where you do actually have security considerations or initialization flows, these vary both by company, and they do fairly heavily depend upon the actual CPU architecture that you're using. And yeah, this has come up a couple of times, and I can see there's probably going to be some kind of need for some standardization on the system components on these. And this may come down to like sub-ecosystems. Maybe you have an ARM, RISC-V, and an x86 ecosystem on how these chiplets standardize. But it's just something to think about, like how do all these things work as you have these more sophisticated chiplets hooking up to each other that are coherent. Another thing that comes up, and this is customers will ask this, and certainly the press loves to talk about this, because I think like the early AMD EPYC processors, they have, oh, what about the NUMA memory? There was non-uniform, there was latency issues. And again, this has been largely addressed, but it comes up over and over again. So maybe this is just a publicity problem. People need to talk about it. We significantly lowered the latency, and it's not anywhere near what it was in some of these early platforms. But I mean, there's just an article written yesterday on ours, and like again, the author was talking about, oh yeah, I'd like to see all these new issues ironed out. So it's something that weighs heavily in people's mind when they're looking at these type of architectures. And then lastly, people ask about packaging, right? So I think it's more of there's just not as much information out there readily available if you're searching for it. Like, hey, how do you package these things up? Packaging is expensive. They're not aware of some of the new packaging technologies that are out there right now. I think I already mentioned substrate. Hey, they're like, hey, there's a silicon substrate issue. Like, and we go, well, we're not even using silicon substrate. We're trying to use organic packaging. But there's a lot of again, it's just, I think more information needs to be out there as far as like what are the packaging solutions for chiplets, because I think there's a lot of confusion. But anyway, I think most people know all these points already, but these are the things that come up in all of our various customer presentations or talking to the press whenever we say we're doing chiplets. So that's what I have.
Hey Travis, what question did you expect would come up but hasn't come up in customer interactions? I think, is there anything that you said, oh, we think this will be an issue, but never really came up?
Oh, well, that's a good question. What question did I expect to come up that didn't come up? I can't really say I have one. The ones they're asking are all on here. I can't say there's anything weighing on my mind that they're missing.
And is anything easier because you're selling a chiplet versus selling a chip?
Pardon?
Is anything easier because you're selling a chip versus a chiplet?
I think Andrew hit on that actually. It's like a lot of these IP costs, because if you, certainly for us, because we're selling a CPU, if you look at it, if you're taking like a high performance IP, CPU IP, everyone's kind of taking the same IP. They're spending a whole bunch of money to go to license it and then to go harden it. And it's very attractive if you're just needing, some kind of standard CPU to just go buy a chiplet rather than have to go through that. That's already hardened in the latest process technology. So people love that. And then they can go focus on what actually makes their chiplet or their system SoC, what do we call these things? SIP, differentiated and valuable.
Thank you.
And that's a huge selling point. Because,
Any other questions for Travis? Hey, thanks for getting us kicked off, man. Appreciate it.
Sure.
Hi, Bobby. I have one thing to share. Actually, it's kind of echo what Alan mentioned, but because the question actually just came up, I'd like to hear from others. What I saw basically in the expo, in the Chiplet Summit, I do see that a lot of people from UCI are actually, the vendors are focusing on the advanced packaging, silicon interposer. Rather than in Bow, we are basically again more on the, I know we support both, but we are more on towards basically organic package like Blue Cheetah and D-Matrix. Do you guys also notice that a lot of people from UCI have a tendency to go to advanced package or not?
Can I address that, Shahab?
Sure.
So, if you start looking at the area impact of, and then the bandwidth requirements, so I think there's a how much bandwidth do I need to go die, and then look at how much area do I need to allocate for that. And the standard packaging, because you're on a kind of 130 micron bump pitch, you're starting to get, let's say, north of a terabit. You're looking at maybe 4 of those clusters, right? The PHY, footprint, right? So that's 4 of those. Let's say you need 2 terabits. That's 8 of them. If you start looking at the area that takes up, it becomes a substantial amount of die area. And it's die area that at package level, the customer doesn't actually see a value, right? If you're putting this together inside a package, you put 2 die together, that's benefiting you, the manufacturer, but at the customer level, that's silicon that they're buying that's not really providing them any functionality, right? It's there to kind of, it's plumbing that they don't see, right? And they're paying for it because it's part of the die area that's being used to go die to die. So if you're looking at bandwidths of north of a terabit, the area impact of using standard packaging becomes substantial.
Thank you.
So Travis, here's what I have as my notes. I'm saying outside the material you covered in your slides, that you should be able to follow the IP integration model when we integrate chiplets. Cost is a special concern because of the overhead that appears, the perceived overhead that appears to be associated with chiplets. So that's why people get to asking you what the floor for chiplets is, cost floor for chiplets is. The third one is, how do you, this may be Anu's point, how do you filter reuse, heterogeneous integration costs and opportunity cost gains with chiplets? Mine was, can we adapt the spreadsheet to a specific architecture rather than being general? And you had a side comment on the spreadsheet today. It really hasn't received a lot of visibility, and maybe we should address that in some fashion. And the advantage of chiplets is customers avoiding IP costs, taking the same IP and hardening it, and instead they get to buy a hardened chiplet. This is what I have in terms of what your slides didn't cover. Does that sound right?
Yeah, that sounds right. And by the way, I don't know, maybe I just haven't looked at the right spot. So for the spreadsheet, it's probably
That's
out
fine.
there.
If it's not visible, it's not visible. We can go fix it. There's a lot of work went into it, so you're a prime candidate to use it. So
Okay.
all right, Nick, we can see your screen.
Yep. Can you see my screen?
Yep.
Okay. So for those of you that were at the summit, this is part of the presentation. I pulled a couple of slides out of there. So Achronix is unique in the industry in that we not only sell packaged FPGAs, we also sell the IP, our FPGA IP, we call it embedded FPGA, to companies that want to integrate it into their SoC to use it for having an FPGA functionality in a product rather than having an FPGA on the side on the board, kind of a separate device. So our business model is the IP is customized FPGA fabric, so we customize it on a per customer basis. The customer chooses the number of LUTs, those are the logic elements, the lookup tables, memory, DSP, and machine learning blocks. Today, we make it available in 16 FFC, 12 FFC, and 7, and it's delivered in GDS format, and it's supported with the Achronix development tools. And as I said, we're the only supplier. So I just want to kind of baseline everybody. This is our current business model of how we enable companies to integrate FPGA into their SoCs. So the natural solution from this is that, well, if you can put it inside of your device, this is our traditional model, you can also then break it out and use it as and put it into a chiplet. And so obviously people are very interested in this because rather than having an off-the-shelf FPGA sitting next to your ASIC SoC, you're able to put in a FPGA chiplet that's optimized for the use case that ASIC SoC has, and therefore it's not, you're not buying a lot of I/O or extra, memory or LUTs that may not be required for your system. You're basically buying it, the chiplet is, quote unquote, optimized to be put in there, and then you can even have another chiplet has some domain IP such as IE that can also be part of the FPGA chiplet or not. So, I started on the chiplet journey a while ago. I've been at Achronix now 2 years, and I kind of kicked off our desire to also look at chiplets for our own use. My two main competitors, Intel and AMD, both use chiplets. They're building blocks, so it's no big surprise that we would also be looking at this as well. So as I got out there and started engaging with customers, I do product planning, product management, so I go out and talk to customers about new products. Customers were like, well, can you show me your chiplet portfolio? And I'm like, well, we don't have a chiplet portfolio. We don't get to use chiplets for our own designs, but I don't have this like parts list of, here's how many LUTs, here's, whatever the case would be. So, the challenge we got into, and I got into, was, selling a standard chiplet. And the issue became, size and resource mix. Vantana, thank you for all the points you made already. But at least you have, we have 4 cores, 8 cores, 16 cores, or you can turn cores off. Unfortunately, the FPGA is a little more malleable on that, and it becomes like, well, I need this many LUTs, that much memory. Well, no, that's too many LUTs. So the size of the FPGA and the resource mix became challenging, right? So and then you say, well, even if you say I'm going to have 3 different sizes, because these are going in the package, and every costs money, there's a lot of cost sensitivity about that. The other one was the aspect ratio of the die. Where are the interfaces, right? So one of the things that there is obviously a chiplet economy out there today. It's called HBM memory, but JEDEC has done a good job of saying, here's the pinout, here's the size, here's the aspect ratio, and you shall live within those bounds. We don't have that today in chiplets, right? It's still the wild, wild west, and people are looking at that and saying, well, what is the aspect ratio that would go into the package? And we're talking about 2 types of packaging here. We're talking about organic substrates, which have a lot more flexibility of how you put die on there, because they're much more tolerant to things like warpage. When you get into things like interposer, silicon interposer, or fan-out RDL, you then have issues where you have to have all the chiplets, when they are down on the package, have to form a rectangle. There can't be any diving boards or anything hanging off, because that causes issues with warpage or issues with how the RDL layers are layered down on top of the device. So this becomes an issue where it says, well, no, your chiplet, when I attach it to my device, is not going to produce a nice even rectangle. So I got to put some dummy die in there, which to rectangle. So that becomes an issue. And then we just talked about this packaging, standard versus advanced. Because some customers are, obviously advanced packaging has a cost factor, so customers are potentially concerned about that, or if that's an issue, right? And then obviously the one that's at least binary is the die-to-die standard. Is it currently between UCIe and a bunch of wires? The ones above it actually have many more degrees of freedom. So today, Aquatics is not selling a standard chiplet because of these issues, right? There's no, but what we are selling is IP. Just what I just said there is, here's how we can license to you our embedded FPGA technology, and you can build your own chiplet. But anybody that is on this call that sells hard IP, there's issues there, which is, well, what process technology do you want that IP? And I just said, well, for us, we have 16, 12, and 7. We're also working on some future nodes, which will make publicly available in the future. But there's one dimension is, all right, which process technology, because it comes with cost and performance. And then once you do have that, there's also the metal stack that says, okay, well, how many layers of metal do you need to implement the FPGA, and then how many metal layers do you need above that to interconnect everything in your die? And so that becomes another variable there, right? So even selling hard IP for chiplets, there are other challenges around what process technology the customer wants to build their chiplet in, and then the metal stack that they want to use as well. So that creates some more variability, but at least it's down to less variables than selling a standard chiplet. Let me open up the questions at this point. Bapi, that's all I have. It's not in depth, actually. The Vantana presentation actually addressed a lot of the same issues.
So I guess the same question I had for Travis. Is there some aspect of chiplets that makes it easier?
Here, well, there's an attractiveness to customers because of what I said is that today they have to buy a device that sits outside of their system, so there's always power and bandwidth, interconnect bandwidth, and they're maybe buying more FPGA than they need. So putting it inside the package is as a chiplet is very desirable from a cost and performance perspective. But we don't have, like I said, a portfolio of these devices. Like I said, we have many more degrees of freedom than even how many cores you're going to put inside a chiplet, right? So that's why we've steered customers to using our embedded FPGA technology to build their own chiplets. which reduces the number of variables. So.
And for designs, if they went for by using your IP and using it in the chiplet instead of integrating with the main die, is there any delta, or is there any pros and cons of one versus the other?
Oh yeah, there is, because so FPGAs are not the most efficient in terms of, if you were to compare ASIC logic density to FPGA logic density, it's a huge delta, because in an FPGA you're buying routing. The thing about FPGAs is there's a logic element and there's a lot of area around it that is used to wire that logic element in many different configurations. So an FPGA, by its nature, is not area efficient. It's logically flexible, but not area efficient. So if you embed it inside of an SoC, you got to be very prudent on how much you put in there, because it could actually become the dominant IP in your device if you want to have a lot of it, right? So putting it off as an FPGA chiplet is very desirable, because it's first of all, you're now limited to the die to just the chiplet. You can choose the process technology of choice, and it's farther down on that nonlinear yield curve, so you're able to price it differently. So there's a lot of, I have many people come up to me at the chiplet summit and ask, well, I'm interested in FPGA chiplets. So there is a desire out there. So not a lack of it. But servicing that market today for us is through an IP play.
Okay. Any other questions for Nick?
This is Bill Chan. I have a question. It seems to me that when you say selling standard chiplets, is that the packaging need to be incorporated into the whole design and not to be a separate design process.
The packaging has to be incorporated, yes. So if you're going to, in any one of these chiplet architectures, obviously you have to co-simulate the electrically the devices using the package as part of the design, because you're communicating through it as as part of your making it look like a single domain. And there's thermal aspects that, and I don't think anybody's here, we haven't spent a lot of time on thermal. There was a vendor, I know that I've talked to them, that does thermal modeling of chiplets inside the package, because you could have two different power domains that have different thermal characteristics, and how does that affect the package and the
the whole design process, from thermal, from mechanical warpage, the performance. I think to get the optimum design, the whole architecture and design need to be taken all together, and not a separate wall between the different people.
Yeah.
I think it's what you have is a really important issue that I brought out. I think it's very, very important. Thank you.
You're welcome. Yeah, I mean, when people design PC boards and they have separate components, at least you have the option of putting different size heat sinks and putting them in different areas where airflow is different. You may not have that ability inside the package, so you have to deal with that thermal profile.
Yes, some of the substrate that we say, oh, it's a substrate, but some of the substrate has especially being used by one of the major chiplet users. The substrate they use is very, very high end and very expensive. I think it's 11 to 11, 10 to 10 kind of substrate. Very, very, it looks like a substrate, but actually it's a very sophisticated substrate.
Yeah, the packaging becomes it becomes a crucial part of this, like I said here.
Yeah. Well, thank you very much for bringing all these issues out.
No problem at all.
Nick, if one of your customers makes an FPGA, I mean, a chiplet, FPGA chiplet with your IP, have you ever served as a matchmaker where you offer to sell that a chiplet to somebody else?
That chiplet, you mean?
Yeah.
I think not yet. No.
Is that something you see happening? That enough of your customers?
Yeah, I mean, if the commercial terms are right, I'm sure we can look at different options, right? If somebody decides to build a chiplet for themselves and they feel that it's general purpose enough that they want to go out and market it, that's the thing about our eFPGA IP is that to make it useful, you have to use our tools, right? So just it's a package deal, right? When we license our eFPGA technology, we also license our software for that specific instance so that customers can program it as though it was a standalone FPGA on a board, right? So, an embedded FPGA is not very useful without the ACE tools that products provides. So anytime that chiplet is, let's say, sold to somebody else, let's say, they're going to need to have access to our tools to actually make it useful, right? Because to load the bit stream, to program it, to simulate it, to all the things, right? So that chiplet kind of has a bungee cord attached to us, whether it's primary customer or through the secondary customer. So yeah, we have to look at that, the economics of how that gets done.
Okay.
Any other questions?
Yeah. Oh, I thought I was.
Yeah.
So here are the notes I have from board to you. You sell FPGA IP. The malleability of FPGAs makes selling a standard chiplet challenging. HBM memory is an example of a chiplet economy. FPGA logic density is lower than ASIC arrangement and routing, so there's an advantage in making it separate chiplet, even when buying IP. Bill had a question about packaging needs to be comprehended into the whole design. You said not just including the thermals. And reselling customer chiplets needs an economic model. Those are the notes I have, right?
Sounds about right.
Okay. Well, thank you. This was way more than I'd hoped. And Bill, do you need to announce the HIR meeting?
Yes, thank you. So HIR, Heterogeneous Integration Roadmap, we will have a annual meeting on February 23 and 24. And then we also have a half-day pre-conference tutorial session. And that is the one that Bobby and I have been talking about, having a chiplet tutorial there, perhaps in the model of open chip. Bobby, what's the word you use? Open chip economy? Open
Yes.
chiplet economy, yeah. So the registration would be, I will send the registration to Bobby and have it distributed. And it's going to be at the SEMI headquarters in Milpitas. And the information will be out at the Electronic Packaging Society webpage. And also I will be sending out the link to the webpage together. So we'd like to invite everyone to attend. We have a very good program with a lot of interesting speakers. So Bobby, thank you very much to give me the opportunity to talk about the annual meeting.
All right. Thank you, Bill. Nick, Travis, many thanks. This was really good and good notes, and hopefully the others will. Anu's just left, but is Marek still here? Or did we lose him too? Okay. Mitch, Marek, Anu, if you could please follow up with Ravi if your companies can do a talk, that'll be great. for 15 minutes. Anybody, if you can think of anybody else who can present, please ping Ravi. And Ravi, anything else you'd like to add?
The only thing I want to add is, so for some of the prospective presenter, I sent a one-pager template. So if you can also use that in your subsequent presentation, that will be great. It will help us in organizing the information in the same way.
All right. Thanks all. Have a great weekend and everything.
Thanks, everyone.